This video is going to introduce the idea of expected value theory. So this is a model or a hypothesis about how we make risky choices. So if we look at the large-scale structure of the diagram here, we have our generic black box, we have stimuli, and in this case what we have is monetary rewards given to people with certain probabilities of winning those rewards, and the response is basically which choice would they like to go for. In the black box we have essentially expected value theory. So this is not necessarily the truth of how people make choices, but this is our a scientific model, a hypothesis about how people might make choices. Now, in this situation, expected value theory would propose that what you would do is to evaluate the expected amount of money, the expected value of each of these choices that you have, and then essentially to pick whichever of the choices which gives you the highest expected value. So one of the questions then is, what is the expected value? Well, if we think about this example here, 20% chance of winning 1,000, let's just think about what might happen if you were to play this game. If you were to play this game, you might either win £1,000, and there's a 20% chance of that happening, but that means there's an 80% chance of you not winning £1,000. Now, any single time you play the game, therefore, you would either get £0 or £1,000. And these are the possibilities. But the proposal of expected value theory is you try to basically think of all the possible outcomes that might happen. What is the average one? What is it that I expect to happen? And so in this example, what you would do is you would take 20% of £1,000. So we do 0.2 times 1,000. And that gives us 200. Okay, that's fine. But what about the expected value of the other choice? 100% chance of 100. Well, that's simple to work out. It's basically 100. We have a complete certainty that if we were to choose that, we would get given £100. So according to expected value theory, a person acting in accordance with expected value theory would be predicted to choose, in this case, 20% chance of £1,000. Now, as a slight aside, we can actually think about what do these expected values mean? These expected values aren't really a property of the external world as such. Instead, they might represent, if you were to sit a participant down and say, do you want 100% chance of £100, or would you like 20% chance of £1,000? Expected value theory would say, well, you calculate the expected values. Okay, fine. Now, these expected values might be considered as an internal representation, maybe even an internal prediction of the average outcome under each choice that you could make. So that's one way of thinking about what these expected values are. So just to kind of work through that, just to kind of elaborate the calculations for anyone who's not quite sure, very often these types of risky choices are actually shortened. So if we look at the bottom example here, if you say there's a 20% chance of winning £1,000, that is a shorthand way of saying, well, yes, there is a 20% chance of winning £1,000, but otherwise 80% of the time you're going to win zero. And so if you work that out, 20% of £1,000 is 200, 80% of £0 is zero, and so the expected value of this particular risky choice here is £200. So that's just hopefully useful for those of you who didn't necessarily understand that. So we can just reiterate that the expected outcome is the kind of monetary reward, if you like, the monetary outcome multiplied by the probability that it will eventuate, that it will take place. But of course, you actually have multiple different types of outcomes. So in this example, you can imagine someone doing like a random number generator or a coin flip or something like this in order to actually work out, okay, well, if you're going to play this game of 20% chance of 1,000, what actually happens on this trial? Are you going to win 1,000? Are you going to win zero? And so the idea is that you're working out the expected outcome of each of these cases and summing them up. So it's relatively simple maths. I just wanted to clarify that the important thing just in English that we're doing is we're taking the probability of getting a certain outcome and multiplying it by the outcome. Now, what can you do with this, with expected value theory? You could create a table which here represents different stimuli. And so the first two columns represents our risk-free bet. And so choice A, the risk-free bet, is always there's a 100% chance of getting this amount of money. And so we can see in the first 4 trials here that I've written down, the participant is offered £100 for sure. And then in the trials following that, they may be offered £900 for sure. Now, choice B, this is the risky choice. In this kind of made-up experiment, we're always offering them £1,000. But what we're changing over trials is the probability that they will get that £1,000 on any given trial. And so you could imagine if your goal was to work out, do people act in this way? What you might want to do is to create a series of predictions of how people should behave if they are maximizing their expected value. And so what we can see is that if the probability of getting the larger rewards here, let's just look at the top line. If we only have a 5% chance of winning £1,000, then our expected value is going to be lower than if we were to pick the £100 for sure. And so this would mean that we would predict that they would choose the £100 for sure. They would choose A. Now, if someone was behaving according to expected value theory, they would actually be indifferent between this next trial where you've got £100 for sure, or you have 10% chance of winning 1,000. And just in case that's not clear, 10% of £1,000 is equal to 100. And so if you're comparing the expected value of each of these options, they would both be £100. And so you would in theory be indifferent between these two choices. But when the probability of winning the £1,000 increases, the expected value goes up above £100, and so the prediction would be that you would choose the risky choice. Now, I've basically given a series of other examples here about what might happen if the amount of money you're given for sure is much higher, so £900 as opposed to 100. And what we can see here is if we just start with the second from bottom line, the penultimate row here, what we can see is that someone behaving according to expected value theory would be indifferent between £900 for sure or 90% chance of £1,000. And again, that's just because 90% chance of winning 1,000 comes up to an expected value of 900, which is equal to the 900 for sure. So that's just a quick run through of the expected value theory and how it works and how you might evaluate expected value theory. I haven't said anything about whether this is a good or a bad model when you empirically test it against people, but I've tried to give you a flavor of how you might actually make these predictions in the first place. And then you can run your experiment with trials that I have here, for example, and then you might add another column which corresponds to the actual choices people make, and you can see whether they are consistent or more consistent or less consistent with the predictions of expected value theory. So that's expected value theory and how you might go about testing its predictions.